Welcome to Astro Odyssey. Explore the universe. For most of human history, Venus was not a nightmare. It was a promise. Long before spacecraft pierced the veil of its clouds, Venus existed only as a light in the sky. Brilliant, unwavering, impossibly beautiful. It rose before the sun and lingered after dusk, earning names like the morning star and the evening star, a celestial companion that seemed to watch over humanity from the heavens. To ancient civilizations, Venus was not merely a planet, but a symbol of love, fertility, rebirth, and divine balance. It was never associated with death, never with destruction, never with fire. When early astronomers turned their telescopes toward Venus, they did not see an inferno. They saw a mystery. Thick, unbroken clouds wrapped the planet completely, hiding its surface from view. And where there is mystery, the human imagination rushes in to fill the void. If Earth had oceans, forests, and life, then surely its near twin so close in size. Mass and composition might have the same. Venus was closer to the sun, yes, but not by much. In fact, for centuries, scientists debated whether Venus might be warmer than Earth, or perhaps simply more humid. Some even speculated it could be younger, still cooling. Its surface covered in shallow seas and endless jungles by the late 19th and early 20th centuries. This vision hardened into near certainty. Venus became a world of swamps and rain, a planet where colossal plants thrived beneath perpetual cloud cover. Writers imagined towering ferns, endless wetlands, and exotic creatures evolving in the planet's dense atmosphere. These were not fringe ideas. They were mainstream scientific speculation, repeated in textbooks, lectures, and popular science magazines. Venus was often described not as hostile, but as overabundant, too alive, too wet, too fertile. Science fiction embraced this idea eagerly. Venus was portrayed as Earth's exotic cousin, dangerous in the way jungles are dangerous, but still livable. Humans could land there, adapt, explore, and conquer. The planet was imagined as a testing ground for survival, not an impossible world. Even as Mars began to lose its romantic appeal, its canals disproven, its atmosphere revealed to be thin and cold, Venus retained its reputation as the most promising second home in the solar system. This belief was not naive optimism. It was logical given what little was known. Venus and Earth formed from the same region of the solar nebula. They are nearly the same size. Their gravity is similar. Their densities are comparable. To early planetary scientists, these similarities suggested parallel histories. If Earth developed life, oceans, and a stable climate, why wouldn't Venus? The clouds were the only obstacle, and clouds, after all, implied weather, rain, cycles, balance, the idea of Venus. As a paradise became so ingrained that it shaped mission planning long before the space age truly began. Early proposals imagined landers splashing down into warm oceans or settling onto solid ground beneath a heavy but breathable atmosphere. Some scientists even speculated that Venus might be more Earth-like than Earth itself, planet without ice caps, where life flourished uniformly across its surface. But beneath this hopeful vision was a critical assumption, one that would prove catastrophically wrong. That similarity in size meant similarity in fate. When humanity finally developed the technology to reach Venus, optimism still lingered. The first probes were built with caution, but not fear. Engineers worried about pressure and temperature, but they did not anticipate total annihilation. There was no expectation that Venus would be fundamentally incompatible with life. If anything, it was seen as a challenge, one that engineering and adaptation could overcome. Then the data began to arrive. The first hints were subtle. It's almost easy to dismiss. Radio observations suggested Venus was unusually warm, but perhaps that heat came from the upper atmosphere. After all, thick clouds could trap warmth near the top, while the surface below remained temperate. Infrared measurements were confusing, contradictory, and incomplete. Each new observation raised questions, but did not yet shatter the dream. It wasn't until spacecraft began their descent through Venus's atmosphere that the illusion truly started to crack as probes fell toward the surface. Temperatures didn't drop, they rose. Pressure climbed rapidly, far faster than expected. Instruments failed one by one, not from random malfunctions, but from overwhelming environmental stress. Sensors designed to withstand extremes simply stopped responding. And yet, even then, the full truth was not immediately understood. Scientists suspected errors, calibration issues, faulty assumptions. Denial lingered because the alternative was unthinkable. If Venus was not a paradise, then what was it? As more missions followed, the picture grew darker literally and figuratively. Every new probe confirmed the same impossible reality. The clouds were not water vapor, but corrosive chemicals. The atmosphere was not life-giving, but crushing. The surface was not a jungle or an ocean floor, but a hellscape baked under relentless heat. The planet did not merely lack Earth-like conditions. It actively destroyed anything that tried to exist there. Venus was not just different from Earth. It was Earth's warning. The realization came slowly, painfully, and against decades of belief. Venus had once been placed in humanity's future, a stepping stone to the stars. Now it was becoming clear that it represented something far more unsettling, proof that two planets born almost identical could diverge into radically different destinies. One becoming a cradle of life, the other becoming a furnace. This was the true betrayal of Venus, not that it was hostile, but that it looked familiar enough to deceive us as the myth collapsed. A new question emerged, one far more disturbing than the old dream of colonization. If Venus could transform so completely, so catastrophically, what protected Earth from the same fate? What thin balance kept our oceans from boiling, our skies from crushing us, our world from tipping into irreversible chaos? Venus stopped being a destination and became a lesson. But even now, long after the fantasy of swamps and jungles has died, the planet continues to tempt us. It sits closer than Mars. Its gravity is comfortable. Its size feels right. And every so often, the old question resurfaces in a new form. What if we could fix it? What if we could tame Venus, cool it, reshape it, claim it? To answer that, we first have to confront what Venus truly is. And to do that, we must descend through clouds of acid into crushing darkness, toward a surface that rejects life with absolute certainty. The belief in Venus as a living world did not exist in isolation. It was reinforced by the limits of human perception itself. Telescopes, no matter how powerful, could not penetrate the planet's permanent cloud cover. Unlike Mars, which revealed deserts, polar caps, and changing surface features, Venus offered nothing but a smooth, blinding disk. There were no visible scars of impact, no continents, no seas, just an unbroken veil. And paradoxically, that emptiness made it easier to believe in abundance. If nothing could be seen, then nothing ugly could be proven. Clouds, after all, are associated with life on Earth. They are signs of weather systems, of evaporation and rain, of a planet that breathes. The idea that clouds themselves could be lethal was foreign to early planetary science. On Earth, even the most violent storms are still part of a living system. No one imagined clouds composed of acid drifting endlessly over a surface hot enough to glow faintly in the infrared. The human mind is deeply uncomfortable with ambiguity. Faced with uncertainty, we default to analogy. Venus looked like Earth in mass and radius, so we assumed it behaved like Earth. This cognitive shortcut shaped decades of thinking. Scientists debated details, temperature ranges, ocean depth, vegetation density, but rarely questioned the underlying premise that Venus was fundamentally Earth-like. The question was never, is Venus habitable? But rather, how habitable is it? Even when skepticism arose, it struggled to gain traction. A handful of researchers warned that Venus might be far hotter than anticipated. But their models relied on early theories of atmospheric physics that were not yet widely accepted. The greenhouse effect, while understood in principle, was not fully appreciated in planetary contexts. The idea that an atmosphere could trap heat so effectively that it would sterilize an entire planet seemed extreme, almost absurd. Earth's greenhouse effect was mild, life-sustaining. Why would Venus's be apocalyptic? There was also an emotional investment at play. Venus represented hope at a time when humanity was first confronting its cosmic smallness. The realization that Earth was not the center of the universe was still fresh in cultural memory. The possibility that another nearby world might host life or even welcome human settlement was comforting. It suggested that Earth was not unique, fragile, or alone. Venus was reassurance written in light. This hope persisted well into the early space age, when rockets finally gave humanity the power to escape Earth's gravity. Venus was an obvious target. It was closer than Mars, requiring less fuel, less time, fewer unknowns. In mission proposals and public discourse, Venus was often framed as the logical first step in interplanetary exploration. If humanity could reach Venus, then the solar system would feel suddenly smaller, more accessible, more human. Popular media amplified this confidence. Educational films depicted Venus as a cloud-covered world with rain-soaked continents below. Illustrations showed explorers wading through shallow seas beneath alien skies. Even as late as the 1950s, respected publications featured artwork of Venusian landscapes filled with strange but thriving ecosystems. These images did not merely entertain, they shaped expectations. They made Venus feel familiar before it had ever been seen. What no one fully reckoned with was how alien familiarity itself can be. Venus's resemblance to Earth turned out to be cosmetic, not functional. Two planets can share mass, size, and origin, and still evolve into radically different systems. This was not yet obvious to early planetary science. Plate tectonics had not been confirmed on Earth. Climate feedback loops were poorly understood. The delicate interplay between atmosphere, oceans, and geology that stabilized Earth's climate over billions of years was only dimly perceived. In retrospect, Venus was never truly Earth's twin. It was Earth's sibling raised in a subtly different environment, pushed just far enough off balance to fall into catastrophe. A little closer to the sun, a little more heat, a little more trapped gas. Small differences compounded over time until recovery was no longer possible. But during the myth-making era, these nuances were invisible. Venus's brightness in the sky further reinforced its allure. It outshines every object in the night sky except the moon. It demands attention. Ancient observers could not help but assign meaning to it. Many cultures linked Venus to creation myths, cycles of death and rebirth, and cosmic order. These symbolic associations lingered, unconsciously influencing how later generations perceived the planet. Venus was not just another rock. It was special, important, benevolent. This symbolism even influenced language. We called it Earth's sister planet, a term that implies kinship and shared destiny. We did not call it Earth's rival or Earth's cautionary tale. Those labels came much later, after the damage was done, after expectations had already been shattered. The true tragedy of Venus is not that it is hostile, but that it teaches hostility through contrast. It shows how close a planet can come to being Earth and how easily it can miss as scientific instruments improved. The myth did not vanish overnight. It eroded. Each new measurement shaved away a layer of optimism. Higher than expected temperatures, strange atmospheric chemistry, pressure estimates that made oceans less plausible. But science advances incrementally, and hope often survives in the gaps between data points. For a time, Venus existed in a limbo state, no longer a clear paradise, but not yet a confirmed hell. This uncertainty was enough to keep the dream alive. It took direct confrontation machines physically entering Venus's atmosphere for illusion to give way to reality. Only when probes began to die, one after another, transmitting final moments of data before being silenced forever, did the truth become undeniable. Venus was not hiding life beneath its clouds. It was hiding violence. Yet even now, with all we know, Venus still exerts a strange pull on the human imagination. Perhaps because admitting that a world so similar to ours became uninhabitable forces us to confront uncomfortable questions about Earth itself. If Venus could fall, then Earth is not guaranteed safety. It is balanced. not blessed. The myth of Venus endured in part because it aligned perfectly with a deeper human impulse: the need to believe that the universe is generous. From the moment humanity realized Earth was not unique in the sky, that planets were common rather than miraculous, a quiet assumption followed. If planets are everywhere, then life must be too. And if life is common, then survival beyond Earth feels inevitable rather than precarious. Venus, glowing so brightly and orbiting so nearby, became the most convenient proof of that belief. This was not arrogance so much as emotional self-preservation. To accept that Earth might be rare, perhaps even fragile, was to accept vulnerability on a cosmic scale. Venus offered an escape from that discomfort. It allowed humanity to imagine redundancy. If one world failed, another awaited. The universe, we told ourselves, had backups. The first machines sent to Venus were built on optimism, tempered by uncertainty, not fear. Engineers knew the planet was warm. They suspected high pressure, but no one truly grasped what waited beneath the clouds. Venus was treated as difficult, not impossible. Dangerous, but not hostile in the way deep space or stellar radiation was hostile. The expectation was survival measured in days, perhaps hours, not minutes. The earliest attempts to reach Venus did not even touch its surface. Flyby missions skimmed past the planet, gathering crude data as they hurtled onward. Even these distant encounters raised eyebrows. Temperature readings were disturbingly high. Radio signals behaved strangely as they passed through the atmosphere. Venus seemed to interfere with instruments in ways that Earth and Mars did not. Still, ambiguity reigned. Without direct measurement, every anomaly could be explained away. Then humanity decided to fall. The first atmospheric probes were blunt. Armored capsules, simple by modern standards, but revolutionary for their time. They were designed to endure extremes, to descend slowly through unknown skies, transmitting data continuously until they reached the surface. Their mission was not exploration in the romantic sense. It was reconnaissance. A question posed in metal and circuitry: what are you really like? As the first probe entered Venus's atmosphere, its instruments came alive. Temperatures climbed immediately, faster than expected. Pressure increased, not gradually, but aggressively, as if the planet were compressing the probe with intent. The data streaming back did not resemble anything from Earth. The atmosphere was overwhelmingly carbon dioxide, with traces of chemicals that hinted at corrosive processes rather than life-sustaining cycles. The clouds, those long-imagined harbingers of rain and fertility, revealed their true nature. They were composed of sulfuric acid droplets, suspended in thick, choking layers that reflected sunlight while trapping heat below. The greenhouse effect here was not subtle. It was total. As the probe descended, the heat did not relent. It intensified. Predictions of warm seas gave way to readings that suggested boiling temperatures. Then, worse. Far worse. The pressure climbed to levels equivalent to being submerged beneath kilometers of Earth's ocean. Any hope of liquid water evaporated, not metaphorically, but literally. One by one, instruments failed. Some sensors overheated. Others were crushed. Electronics shorted. Data streams became erratic, then silent. The probe did not reach the surface so much as it succumbed to it. Its final transmission was not an image or a triumphant discovery, but a confirmation of loss. Venus had spoken, and its message was clear: you do not belong here. At first, disbelief followed. Engineers and scientists combed through the data, searching for errors. Had the heat shield failed? Had the pressure sensors malfunctioned? Was the descent profile wrong? These were reasonable questions. After all, no one wanted to accept that an entire planet could be so fundamentally incompatible with survival. But Venus was relentless. Every subsequent probe told the same story, with increasing clarity and precision. Some lasted longer, transmitting 4 minutes on the surface before being silenced. Others died before reaching the ground. None survived long enough to suggest adaptation was feasible. The surface of Venus revealed itself not as a place, but as a condition. Temperatures hovered around levels that could melt lead. The atmosphere pressed down with a force 90 times greater than Earth's sea level pressure. Winds screamed through the upper atmosphere at unimaginable speeds, while the surface itself lay in a suffocating stillness. There was no water, no soil, no refuge. Only rock baked into near permanence by unyielding heat. Photographs, when they finally arrived, were haunting in their mundanity. Flat, cracked landscapes. Jagged stones. A sky tinted yellow and orange by dense clouds. No dramatic volcanoes erupting in frame. No oceans boiling visibly. Just an oppressive emptiness that felt final. Venus did not look alive, nor did it look recently dead. It looked resolved. With each mission, the fantasy unraveled further. Venus was not merely too hot. It was hot in a way that suggested inevitability. Its climate was stable, but stable in catastrophe. The runaway greenhouse effect had long since completed its work, locking the planet into a state from which escape was impossible without intervention on a planetary scale. This realization changed how scientists spoke about Venus. The language shifted from harsh environment to extreme system, from challenging conditions to terminal climate state. Venus was no longer a candidate for colonization. It was a boundary, a limit case that defined what planets could become when balance was lost. The shock rippled outward. If Venus, once thought so similar to Earth, could become this hostile, then planetary habitability was clearly more fragile than assumed. The comforting idea that Earth-like planets naturally tend toward life-friendly conditions began to erode. Instead, habitability appeared rare, fleeting, and dependent on a narrow window of variables aligning perfectly. Venus forced scientists to confront the idea that planets do not care about life. There is no malice in Venus's atmosphere, no intention in its crushing pressure. The planet is not angry. It is indifferent. It obeys physical laws with absolute consistency. And those laws happen to produce a world that annihilates biology as thoroughly as vacuum or radiation ever could. By the time the last of the early probes transmitted their final data, the myth of Venus was dead. Not wounded. Not revised. Dead. In its place stood a new understanding. Venus was not a failed Earth. It was a successful Venus, a planet that followed its evolutionary path to completion, regardless of how inhospitable the result might be to us. And yet, even in this devastation, Venus offered knowledge. Its extreme conditions became a laboratory for understanding atmospheric physics, climate feedbacks, and planetary evolution. The planet that could not be touched could still be studied, and in doing so, it began to teach humanity something far more valuable than a second home. It taught us how worlds die, but the story does not end with discovery. Because once the reality of Venus was known, a new question emerged, one driven not by fantasy, but by defiance. If Venus is this hostile, could it ever be changed? That question, dangerous, ambitious, and deeply human, is where the next part begins. As missions to Venus multiplied, so did the sophistication of the questions being asked. No longer was the goal simply to measure temperature and pressure. Scientists wanted to understand why Venus had become what it was. Each probe was now a forensic tool, sent to examine the scene of a planetary catastrophe long after the event had concluded. Later probes were designed with thicker shells, improved insulation, and redundancies layered upon redundancies. Engineers accepted that survival would be brief and planned accordingly. Instruments were prioritized. Some would fail early. Others might last just long enough to answer a single critical question. Time itself became a resource to be rationed in seconds as these probes plunged through the atmosphere. They revealed a structure that was both alien and eerily organized. Venus's atmosphere was not chaotic. It was stratified, layered like an immense chemical machine. Above the clouds, conditions were deceptively mild. Temperatures and pressures briefly approached levels humans might tolerate. This thin region where sunlight scattered through pale skies would later tempt future thinkers into imagining floating cities and aerial colonies. But the illusion did not last. Below, the atmosphere thickened dramatically. Carbon dioxide dominated almost entirely, crowding out any trace of oxygen. Nitrogen, a stabilizing presence in Earth's atmosphere, was relegated to a minor role. The sheer mass of gas pressing downward created a crushing weight, the one that intensified relentlessly with every kilometer of descent. The greenhouse effect here was no longer an abstract concept. It was visible in the data. Sunlight entered easily, filtered through clouds that reflected much of it back into space, but not enough. Heat radiated upward from the surface and was trapped, absorbed, re-emitted, and trapped again. There was no equilibrium. No seasonal variation. Venus had crossed a threshold and never looked back. When probes finally reached the surface, the environment they encountered defied intuition. Despite the planet's slow rotation and lack of weather at ground level, the heat was uniform, omnipresent, and unrelenting. There were no cool nights, no shade, no refuge behind rocks or within valleys. Venus did not offer microclimates. It offered only one climate, everywhere, all the time. The pressure alone was enough to kill instantly. Human lungs would collapse before they could draw a breath. Blood would fail to circulate properly. Even without the heat, even without the toxic gases, Venus would be fatal. Combined, these factors made survival not merely unlikely, but physically impossible without technology so advanced it borders on fantasy. Some probes managed to transmit images before succumbing. These images were grainy, color-distorted, and fleeting, but they were real. For the first time, humanity saw Venus not as a point of light or a painted illustration, but as a place that existed independent of imagination. The surface looked ancient and scarred, shaped by volcanic forces rather than water or life. Vast plains of solidified lava stretched into the distance, interrupted by fractured rock formations that hinted at immense geological stress. Volcanoes appeared everywhere, not explosive in the way Earth's often are, but vast and diffusive, bleeding molten rock across the surface over immense spans of time. Venus, it seemed, had never cooled enough to rest. Its interior heat still found pathways outward, reshaping the planet again and again beneath its crushing atmosphere. This geological activity added another layer to the planet's hostility. Volcanic gases replenished the atmosphere continuously, reinforcing the greenhouse effect rather than allowing it to dissipate. On Earth, plate tectonics and oceans act as regulators, cycling carbon back into the crust. On Venus, those mechanisms were absent or ineffective. Carbon remained in the sky, where it could do the most damage, as the data accumulated. A chilling conclusion formed: Venus was not simply unlucky. It was locked. The planet had entered a stable state of extreme heat and pressure that could persist for billions of years. There was no natural process left that could reverse it. No gradual cooling. No atmospheric thinning. No return to habitability. Venus had crossed a one-way boundary in planetary evolution. This realization reframed everything. The question was no longer, why is Venus so hot? But how close did Earth come to the same fate? The similarities that once inspired hope, now inspired unease. Earth and Venus may have started with comparable inventories of water and carbon. If so, then Earth's survival depended on a series of fortunate divergences distance from the Sun. Magnetic protection, active plate tectonics, and perhaps sheer chance, Venus became a case study in planetary mortality. Scientists began referring to it not as Earth's twin, but as its counterfactual. A version of Earth where things went wrong. This framing was powerful because it stripped away the comfort of inevitability. Life was not guaranteed. Stability was not permanent. Even planets that look safe can drift into disaster if the balance tips too far. The emotional weight of this shift seeped into the broader culture of space exploration. Venus missions became quieter, less celebrated. There were no dreams of colonists or cities, only data returns and post-mission reports. The planet had been demoted from future home to hostile archive. Yet Venus did not fade into irrelevance. On the contrary, it became more important than ever. Every measurement refined climate models. Every failed probe validated theories about atmospheric collapse. Venus became the benchmark for worst-case scenarios, the upper bound of greenhouse warming. In this way, Venus continued to shape humanity's future, not as a destination, but as a deterrent. The surface of Venus is a graveyard. Its atmosphere is the executioner. From a distance, Venus's atmosphere appears almost gentle as soft, reflective shell that scatters sunlight and glows faintly against the blackness of space. It is easy to mistake this brightness for safety. On Earth, clouds mean rain, moderation, and life-sustaining cycles. On Venus, clouds mean something very different. They are not a shield. They are a weapon. The moment a human-made object enters Venus's atmosphere, it encounters an environment that violates nearly every assumption we hold about air. This is not merely an absence of oxygen. It is not simply toxicity layered on top of pressure and heat. Venus's atmosphere is hostile in a way that is systemic. It attacks biology, machinery, and structural integrity all at once, across every altitude. At the highest levels of the atmosphere, conditions initially seem deceptively manageable. Temperatures and pressures briefly approach those found on Earth. This thin band tens of kilometers above the surface has often been cited as evidence that Venus is almost habitable. It is here that proposals for floating cities and aerial colonies take root. The idea is seductive. Avoid the surface. Live in the sky. But this region is a trap. The air here is still overwhelmingly carbon dioxide. Oxygen is virtually non-existent. Nitrogen, which buffers Earth's atmosphere and stabilizes pressure, plays only a minor role. The chemistry is already hostile, already corrosive, already incompatible with human life without complete environmental isolation. And isolation is only possible if structures remain intact, something Venus does not allow for long. Descending deeper, the atmosphere thickens rapidly. Pressure rises not gradually, but exponentially. Every kilometer downward adds weight, compressing gas into an ever-denser fluid. At lower altitudes, Venus's atmosphere behaves less like air and more like an ocean one, made of hot, suffocating gas. The composition of this atmosphere is the result of a planetary feedback loop gone unchecked. Carbon dioxide dominates, accounting for more than 96% of the total volume. On Earth, carbon dioxide is a trace gas essential, but carefully balanced by oceans, rocks, and life. On Venus, it is everything. This matters because carbon dioxide is exceptionally good at trapping heat. Once sunlight penetrates the cloud layer and warms the surface, that heat has nowhere to go. Infrared radiation is absorbed, re-emitted, and absorbed again, trapped in a cycle that intensifies rather than stabilizes. The atmosphere becomes both blanket and prison. Adding to this is sulfur. Venus's clouds are composed primarily of sulfuric acid droplets, suspended in dense layers that stretch for kilometers. These clouds do not produce rain in any meaningful sense. Any liquid that forms evaporates long before it can reach the surface. Instead, the acid circulates endlessly, a corrosive aerosol that eats away at exposed materials. For human technology, this is devastating. Metals corrode. Polymers degrade. Protective coatings fail. Any long-term structure would need to withstand not only extreme heat and pressure, but continuous chemical assault. Maintenance already difficult in space would be nearly impossible in an environment that destroys tools as quickly as it destroys habitats. And then there is the pressure. At the surface of Venus, atmospheric pressure is equivalent to being nearly a kilometer beneath Earth's oceans. This is not pressure that humans can adapt to biologically. It collapses lungs, distorts blood flow, and prevents normal cellular function. Even hardened deep-sea organisms on Earth would not survive Venus because the temperature compounds the problem. Heat and pressure together create conditions that dismantle life at a molecular level. Proteins denature. DNA breaks down. Enzymatic processes fail. Even extremophiles organisms that thrive in boiling springs or acidic pools on Earth are helpless here. Venus does not exceed life's limits in one dimension. It exceeds them in all of them at once. The atmosphere also erases time. On Earth, weather brings change. Winds redistribute heat. Storms cleanse the sky. Seasonal cycles introduce variation. Venus has winds too, some of the fastest in the solar system, but they exist primarily in the upper atmosphere, whipping clouds around the planet at hundreds of kilometers per hour. Near the surface, the air barely moves. The weight of the atmosphere suppresses turbulence, locking heat in place. This means that Venus offers no respite. There are no cold fronts, no storms to break the monotony, no nighttime cooling. The planet rotates so slowly that a single day lasts longer than a year, but this barely matters. The atmosphere equalizes everything. Venus does not experience time the way Earth does. It experiences permanence. For colonization, permanence is death. Human survival depends on margins ranges within which systems can fail and recover. Venus has no margins. A habitat breach is instant catastrophe. A cooling failure is terminal. A chemical leak is unrecoverable. There is no environment to fall back on, no external buffer to absorb mistakes. Even communication is affected. Venus's dense atmosphere interferes with radio signals, complicating surface-to-orbit transmissions. Any permanent presence would need constant relay infrastructure, itself exposed to the same hostile conditions. Every layer of complexity multiplies failure points in a place where failure is absolute. This is why Venus does not merely resist colonization, it repels it. Mars is cold, but cold can be managed. Pressure can be increased. Atmospheres can be built. Radiation can be shielded. Venus offers no such footholds. Cooling a habitat is not enough when the outside temperature never drops. Reinforcing structures is futile when pressure and corrosion are constant. Terraforming is not just difficult, it is antagonized by every natural process on the planet. Venus's atmosphere is not passive. It is an engine actively maintaining its own hostility. Any attempt to change it must fight the planet continuously forever. Stop intervening. And Venus reasserts itself immediately. This is the crucial difference between Venus and other hostile worlds. Mars is dead but pliable. Venus is alive with physics. Venus does not fail to support life because it lacks something. It fails because it has too much atmosphere, too much heat, too much pressure, too much chemical aggression. It is excess taken to its logical extreme. Understanding this reframes the entire colonization question. Venus is not waiting to be fixed. It is not broken. It is functioning exactly as its conditions demand. And that means any attempt to live there is not adaptation, is defiance. The most deceptive aspect of Venus's atmosphere is that it does not feel chaotic. There are no constant storms at the surface, no violent turbulence tearing landscapes apart. From a purely mechanical standpoint, Venus is eerily calm, and that calmness is precisely what makes it so lethal. On Earth, danger is often episodic. Storms pass, heat waves break, disasters recede. On Venus, danger is ambient. It is the background condition of reality. Every breath a human might try to take on Venus would be a mistake measured in milliseconds. The atmosphere contains virtually no oxygen, but suffocation would not be the primary cause of death. Long before oxygen deprivation mattered, the sheer density of the air would crush lung tissue, preventing expansion. Inhaling would be impossible not because there is nothing to breathe, but because the body cannot physically move against the pressure. Even if a hypothetical breathing apparatus supplied oxygen at the correct pressure, the heat would destroy lung tissue almost instantly. Air entering the body would be hot enough to cause internal burns. The bloodstream itself would struggle to function, as dissolved gases behave differently under such extreme pressure. Human physiology, evolved for a narrow band of conditions, would unravel immediately. And biology is only the beginning. Machines fare no better. Electronics rely on precise tolerances temperatures, within which semiconductors behave predictably. Venus exceeds those tolerances everywhere below the cloud tops. Cooling systems would be overwhelmed continuously, not intermittently. There would be no night to recover lost thermal ground. Heat would accumulate relentlessly, pushing systems toward failure, even if they were theoretically designed to operate at extreme temperatures. Pressure compounds this problem. Seals deform. Structural joints creep and weaken. Materials that are stable on Earth become brittle or plastic under Venusian conditions. Even metals change behavior when subjected to sustained heat and compression. Over time measured in minutes or hours, not years, structures would sag, warp, and fail. Then comes corrosion. Sulfuric acid clouds do not simply coat surfaces. They infiltrate. Acid vapors penetrate microscopic imperfections, accelerating chemical reactions that eat away at protective layers. On Earth, corrosion is a slow enemy, fought with maintenance and replacement. On Venus, corrosion is rapid and unavoidable. Any long-term structure would require constant renewal in an environment that destroys tools, lubricants, and replacement parts as fast as they are deployed. This makes the idea of permanence on Venus almost nonsensical. Colonization is not merely about survival, it is about continuity, repairing damage faster than it accumulates. Venus ensures the opposite. Damage is guaranteed. Repair is optional but futile. Even the concept of shelter loses meaning. On Earth or Mars, habitats isolate humans from an otherwise survivable environment. On Venus, isolation must be total and flawless. A microscopic breach is not an inconvenience, it is annihilation. There is no grace period. No evacuation window. No second chance. This unforgiving nature extends upward into the atmosphere itself. While the upper cloud layers are often cited as Earth-like in pressure and temperature, this comparison is dangerously incomplete. The chemistry remains toxic. The clouds are acidic, and the winds racing at hurricane speeds around the planet create shear forces that would stress any floating. A floating city would not rest peacefully. It would fight to remain intact every second of its existence. And even if such a structure could be built and maintained, it would still depend entirely on imported materials, energy, and life support systems. Venus offers nothing to work with. No water to harvest. No breathable gas to refine. No safe raw materials to process locally. Every gram of usable matter would need to be shipped in or endlessly recycled under hostile conditions. This is the ultimate indictment of Venus's atmosphere. It is not merely unlivably, it is uncooperative. Mars, for all its cold and thin air, allows modification. Pressure can be increased locally. Heat can be generated. Ice can be melted. Venus allows no such footholds. Any attempt to alter local conditions is immediately overwhelmed by the surrounding environment. The atmosphere presses in, heats up, corrodes, and reasserts control. The planet does not tolerate pockets of resistance. From a systems perspective, Venus's atmosphere behaves like a closed loop, optimized for stability at extreme values. It is self-reinforcing. Add heat and it traps more. Remove gas, and volcanic outgassing replaces it. Attempt to cool the surface, and the atmosphere redistributes energy until equilibrium is restored. That equilibrium is hell. This is why Venus is often misunderstood in popular discussions. People ask, why not just remove the atmosphere? Or why not cool it down? These questions assume the atmosphere is a layer that can be peeled away or adjusted. In reality, it is the planet's defining feature. It is integrated into Venus's geology, chemistry, and thermal balance. Removing it would require energy on a scale comparable to the planet's total gravitational binding energy. In other words, you would need to fight Venus itself. Every hostile world eventually inspires the same question, not because it is sensible, but because it is human. What if we could change it? Venus, more than any other planet, provokes this impulse. Its size is right. Its gravity is comfortable. Its proximity is tempting. Unlike Mars, it does not feel small or fragile. Venus feels substantial. And that substance makes it dangerously easy to believe it could be reshaped with enough intelligence, enough power, enough time. Terraforming Venus is often framed as the ultimate engineering challenge. A test of whether humanity is merely a passenger in the universe or a force capable of rewriting planetary destiny. On paper, the problem seems deceptively straightforward. Reduce the temperature, thin the atmosphere, neutralize the chemistry, add water, and wait. In reality, Every one of those steps collides with a system that resists change at every level. The first and most obvious obstacle is heat. Venus's surface temperature is not marginally too hot. It is catastrophically so. Any attempt to cool the planet must remove an almost unimaginable amount of energy. This is not a matter of shading the surface or tweaking atmospheric composition slightly. The heat trapped in Venus's atmosphere represents billions of years of accumulated imbalance. One popular proposal imagines placing enormous reflective mirrors in space to block sunlight from reaching the planet. In theory, less incoming energy means cooling over time. In practice, this idea collapses immediately. Even if sunlight were reduced dramatically, Venus's thick atmosphere would retain heat for tens of thousands of years. The planet would cool slowly, if at all, and any failure in the mirror system, any gap, any degradation, would allow heat to build back up. Terraforming cannot tolerate interruptions. Venus demands perfection over geological timescales. Then there is the atmosphere itself. Venus's atmosphere is not just thick, it is massive. Stripping it away would require either removing carbon dioxide molecule by molecule or converting it into something else. Both options are absurdly energy-intensive. Proposals range from chemically binding carbon dioxide into solid compounds to launching the atmosphere into space using some planetary scale mechanism. The numbers involved are staggering. The energy required rivals that of asteroid impacts or stellar processes. Even if humanity could marshal such power, the effort would need to be sustained continuously to counteract volcanic outgassing, which would slowly but relentlessly rebuild the atmosphere from below. Venus does not merely have an atmosphere. It manufactures one. And even if, through some miracle, the atmosphere could be thinned and cooled, another problem emerges: water. Venus has almost none. Any early oceans it once possessed were lost long ago. Hydrogen escaped into space. Oxygen reacted away or vanished. Reintroducing water would require importing it in quantities so vast they defy logistics. Comets, icy moons, artificial synthesis, none of these approaches scale remotely close to what would be needed to create stable oceans. But even if water were somehow added, Venus would not know what to do with it. Without plate tectonics to regulate carbon cycles, without a magnetic field to protect the atmosphere, without stable rotation to drive weather patterns, water would be temporary at best. It would evaporate, dissociate, escape. The planet would slide back toward its original state. Not because it wants to, but because physics insists this is the core understanding behind terraforming Venus, the assumption that planets are clay. They are not. Planets are processes. They are dynamic systems shaped by feedback loops, energy flows, and deep time interactions between geology and atmosphere. Venus's current state is not a surface problem. It is a system-wide equilibrium. Changing it requires changing everything at once, and then maintaining that change forever. This is where floating cities enter the conversation. Unlike full terraforming, floating habitats appear more modest. Instead of reshaping the planet, the idea is to exploit a narrow altitude band where temperature and pressure are relatively Earth-like. Balloons or aerostats filled with breathable air could, in theory, float naturally in the dense carbon dioxide atmosphere. On paper, this seems clever, elegant. A workaround rather than a conquest. But this idea, too, unravels under scrutiny. First, the chemistry. Those habitable layers are embedded in sulfuric acid clouds. Any floating structure would be bathed continuously in corrosive aerosols. Materials would degrade. Seals would fail. Maintenance would be constant hand. Maintenance requires exposure. Second, the winds. Venus's upper atmosphere moves at astonishing speeds, circling the planet far faster than the planet rotates. Floating habitats would experience relentless shear forces, stressing structures continuously. Anchoring is impossible. Stability is an illusion. Third, and most critically, dependency. A floating city on Venus would produce nothing. No food, no water, no raw materials. Every necessity would need to be imported or perfectly recycled. There is no surface industry to support orbital infrastructure. No local ecosystem to draw from. The city would be an island, not in an ocean, but in a hurricane of acid. Such a habitat would not be a colony. It would be a permanent experiment balanced on failure, even assuming flawless engineering. The purpose of such a city remains unclear. Colonization implies expansion, reproduction, sustainability. A floating Venus habitat would offer none of these. It would be fragile, finite, and utterly dependent on continuous support from elsewhere. In other words, it would not represent humanity becoming multiplanetary. It would represent humanity refusing to let go. Venus resists terraforming, not because we lack imagination, because imagination cannot substitute for planetary scale feedback. Every attempt to impose order on Venus must fight against heat that never stops, pressure that never relents, and chemistry that never rests. And this resistance is not malicious. It is indifferent. That indifference is what makes Venus so important. It demonstrates that intelligence does not grant immunity from physical law. That ambition, no matter how vast, cannot override systems that operate on scales far beyond human experience. Terraforming Venus no longer feels bold. It feels revealing. It exposes a human tendency to mistake proximity for possibility and resemblance for compatibility. Venus is close but unreachable, familiar but alien, tempting but final. And in confronting that reality, humanity is forced to look elsewhere. Not just for new homes, but for lessons. Because Venus's greatest value is not as a destination to be conquered, but as a boundary to be respected. And that boundary has something to teach us about Earth. One of the reasons terraforming Venus remains such a persistent idea is that it appeals to a very specific narrative, that intelligence is destiny. The belief that once a species becomes technologically advanced enough, no environment is truly off-limits zone, temporarily inconvenient. Venus challenges that belief more brutally than any other world we know. At the heart of most Venus terraforming proposals lies a single assumption: that the planet's current state is a mistake, that something went wrong, and that with sufficient knowledge, it can be corrected. But Venus is not broken. It is complete. Its climate, atmosphere, geology are not malfunctioning. They are working together in a stable configuration that simply excludes us. This distinction matters because it reframes terraforming from repair to replacement. To make Venus habitable is not to improve it, but to dismantle it and build a different planet in its place. Consider again the idea of removing Venus's atmosphere. Often described casually: strip the sea. Oh, lock it into rock. Export it to space. These phrases conceal the scale of the task. Venus's atmosphere contains more carbon dioxide than all of Earth's fossil fuels combined by orders of magnitude. Binding it chemically would require raw materials that Venus does not have in accessible form. Exporting it would require lifting an entire atmosphere out of a gravity well nearly as deep as Earth's, and even if such a feat were possible, would not be permanent. Venus's interior is still active. Volcanoes, the surface. Gases continue to escape from the mantle. Over time, perhaps tens of thousands of years, perhaps less, the atmosphere would begin to rebuild itself. Terraforming Venus would not be a project with an end date. It would be a commitment without exit. This exposes a rarely discussed truth. Terraforming Venus would require eternal maintenance. Stop intervening, and the planet reverts. No other major terraforming target demands this level of perpetual defiance. Mars, modified, might remain stable for long periods. Venus would not. Venus would remember what it was. Another proposal imagines freezing Venus, schooling it until atmospheric gases condense and fall to the surface as solids. This idea hinges on drastically reducing solar input and waiting for temperature to drop. But Venus's atmosphere is so effective at retaining heat that cooling it is not just slow, it is asymptotic. The closer you get to condensation temperatures, the harder it becomes to remove the remaining heat. Meanwhile, condensed gases would blanket the surface in layers of solid carbon dioxide and sulfur compounds, creating a planet-sized chemical minefield Any warming natural or accidental would cause these materials to sublimate, flooding the atmosphere again in a violent reversal. This is the theme that repeats endlessly in Venus terraforming concepts. Reversibility is always waiting. The planet is not delicately balanced. It is entrenched. Floating cities, often presented as a pragmatic compromise, suffer from a different but equally fatal flaw. They mistake survivability for habitability. Yes, there exists a narrow altitude where pressure and temperature approximate Earth norms. But habitability is not defined by two variables. It is defined by systems food production, waste recycling, psychological health, redundancy, and resilience. A floating habitat on Venus would be a closed loop with no slack. Agriculture would depend on artificial light or filtered sunlight. Water would need to be endlessly purified and recycled. Any failure in these systems would be catastrophic because there is no external environment to lean on. Worse, such habitats would exist in a chemically aggressive atmosphere that actively degrades infrastructure. Maintenance crews would operate in conditions where exposure is lethal, requiring layers of protection that themselves degrade over time. Repair would always lag behind decay, and decay is guaranteed. This makes Venus unique among hostile environments. In Antarctica, decay is slow. In orbit, decay is manageable. On Venus, decay accelerates. There is also the psychological dimension, often ignored in technical discussions. Human beings do not thrive in environments where survival depends on perfect isolation forever. Even submarines and space stations rely on the knowledge that rescue, evacuation, or return is possible. Venus offers none of these assurances. A Venus habitat would not feel like a frontier. It would feel like a siege. Every window would look out on clouds that kill. Every system alarm would carry existential weight. There would be no wilderness to explore, no surface to walk, no gradual acclimatization. Colonists would not adapt to Venus. They would hide from it indefinitely. That is not colonization. It is confinement. The desire to terraform Venus says more about us than it does about the planet. It reflects a refusal to accept limits. A belief that every problem is solvable if approached at sufficient scale. Venus pushes back against this belief, not with drama, but with inevitability. No matter how clever the proposal, no matter how ambitious the timeline, the same conclusion emerges. The cost is infinite, the maintenance is eternal, and the benefit is questionable. Why do all this to create a second Earth, when Earth already exists? This question cuts deeper than engineering. It exposes the emotional core of Venus terraforming fantasies. They are not driven by practicality. They are driven by anxiety about Earth's fragility, about the future. It's about the fear that we might not deserve the planet we already have. Venus becomes a projection screen for that anxiety. If we can fix Venus, then perhaps we can fix anything. If we can conquer hell, then no mistake is final. But Venus refuses to play that role. It stands as proof that some mistakes, natural or otherwise, are permanent. That some systems, once pushed too far, do not come back. And that intelligence does not grant exemption from consequence. Terraforming Venus is no longer a serious proposal. It is a thought experiment that collapses under its own weight. A mirror held up to human ambition, showing both its brilliance and its blindness. Venus cannot be saved, and not because we lack power, but because saving it would require becoming something other than human, species willing to commit infinite effort for finite gain. Forever, and that realization reframes the entire discussion. Because if Venus cannot be changed, then the only planet we truly control is the one we are standing on now. Once Venus was stripped of its myths, once its heat, pressure, and chemistry were laid, bare it ceased to be merely a hostile planet and became something far more unsettling. A case study in planetary failure that looks uncomfortably familiar, not identical to Earth, but close enough to matter, close enough to warn. For the first time, humanity possessed a real example of a world that may have started with oceans, sunlight, and chemical potential, and lost them all without a single catastrophic event. No asteroid impact, no stellar flare, no sudden annihilation. just a slow drift past a boundary it could not return from. Venus shows us that planets do not need to explode to die. They can simply overheat. This realization fundamentally altered how scientists think about climate, not just on Venus, but on Earth. Before Venus, climate was often treated as a system that naturally oscillates within survivable bounds. After Venus, it became clear that oscillation has limits. Feedback loops can reinforce themselves. Thresholds can be crossed. Stability can be lost permanently. The runaway greenhouse effect is not a theory born of computer models alone. It is written across the surface of Venus. What makes this comparison so disturbing is not that Earth is identical to Venus isn't but that the underlying physics is shared. The same greenhouse gases, the same solar input mechanisms, the same thermodynamic principles. Earth avoided Venus's fate, not through destiny, but through balance. That balance is thinner than it looks. On Earth, carbon dioxide is regulated by oceans, weathering, biology, and plate tectonics. Each of these systems absorbs stress from the others. When one weakens, the rest compensate. Venus appears to have lost that redundancy early. Once water began to disappear, regulation collapsed. Feedback turned amplifying. Recovery ceased to be possible. Earth's safety net exists, but it is not infinite. Venus demonstrates that climate change is not just about temperature rise. It is about system behavior. Small increases can trigger non-linear responses. Delays matter. Once certain thresholds are crossed, mitigation becomes irrelevant. Adaptation becomes impossible. This is why Venus looms so large in climate science discussions. It is not a prediction. It is a boundary condition. It defines what happens when greenhouse warming escapes control, and no stabilizing forces remain to stop it. The most unsettling lesson Venus offers is that habitability is not a right. It is a temporary state maintained by processes that must continue working. Earth is habitable because countless systems align just well enough, just long enough. Venus shows us what happens when alignment fails, and yet the temptation to dismiss Venus remains strong. Earth has oceans. Venus does not. Earth has life. Venus does not. Earth has plate tectonics. Venus does not. These differences are real, but they are not comforting. They do not guarantee permanence. They simply explain divergence. They tell us why Earth survived so far, not why it will always do so. Venus teaches us that the most dangerous changes are not dramatic. They are cumulative. Slow enough to ignore, easy to rationalize. By the time their consequences become undeniable, the system has already committed to an outcome. This is why Venus is not a metaphor. It is evidence. The planet stands as proof that climate can reach a point where discussion becomes academic and intervention becomes symbolic. A world where physics has already decided the outcome, and intelligence arrives too late to matter. That possibility that intelligence can be outpaced by consequences, the true horror of Venus, and it reframes humanity's future in space. If Earth is not guaranteed, then colonization is not an escape hatch. There is no easy second home waiting nearby. Mars is marginal. The moons are hostile. Venus is closed. Earth is not just our cradle, it is our refuge. This is the inversion Venus forces upon us. Instead of asking how we can leave Earth, it asks why we are risking the only planet that has not already failed. Venus also reshapes how we search for life beyond the solar system. It warns against superficial similarity. Size, distance, and mass are not enough. A planet can look Earth-like and still be dead. It can orbit in the habitable zone and still be uninhabitable. Context matters. History matters. Feedback matters. In this way, Venus becomes a teacher rather than a threat. It teaches humility. It teaches restraint. It teaches that survival is not about dominance over nature, but alignment with it. That the universe does not owe us habitable worlds. That life persists, not because conditions are generous, but because they are temporarily forgiving. Venus is no longer an enemy or a challenge. It is a monument to what happens when balance is lost, and to how unforgiving planetary physics can be. once it is. And yet, this is not a message of despair, because Venus also tells us something hopeful. Earth did not become Venus. Not yet. Somehow, through chance and structure and life itself, Earth remained on the right side of catastrophe. That means thresholds exist and that staying below them matters. The lesson of Venus is not that doom is inevitable. It is that prevention is priceless. The tragedy of Venus is that it cannot be saved. The opportunity of Earth is that it still can be. And that brings us to the final movement of this story, not outward, but forward, toward what Venus ultimately represents in humanity's long journey into the cosmos. Venus ends the argument humanity has been quietly having. With the universe since the first rockets left Earth, it answers a question we rarely ask directly, but constantly imply. Is there anywhere we cannot go? For much of modern history, the answer has felt like not yet, not with our current technology. Not with our current energy sources. Not with our current understanding. The assumption has always been that limits are temporary, that every boundary is just a problem waiting to be solved. Venus is where that assumption fails. Not because we lack imagination. Not because we lack intelligence. But because the universe does not recognize ambition as a force of nature, Venus teaches us that expansion is not guaranteed. That proximity does not equal accessibility. That some worlds exist not as future homes, but as finished stories. It reminds us that the cosmos is not designed for us and that survival beyond Earth is not about claiming territory, but about recognizing compatibility. This is the hardest lesson for a spacefaring species to accept, because exploration has always rewarded boldness. Crossing oceans, climbing mountains, orbiting planets, every boundary humanity has faced so far has eventually yielded. Venus is the first nearby world that does not yield at all. It does not compromise. It does not soften with understanding. It does not offer a foothold for persistence. It simply remains what it is. And in doing so, Venus redraws the map of the future. It tells us that becoming a multiplanetary species is not a matter of willpower alone. It is a matter of environments that allow us. Mars allows difficulty. The moon allows fragility. The outer moons allow patience. Venus allows nothing. This forces a fundamental shift in how we think about space exploration. The future is not about spreading everywhere. It is about choosing carefully. About identifying worlds that can be lived with, not conquered against. About recognizing that survival favors harmony, not dominance. Venus also reframes heroism. There is a romantic idea that the most advanced civilizations will reshape planets, rewrite atmospheres, and bend worlds to their needs. Venus shows the opposite. It suggests that the most advanced civilizations may be the ones that don't try. The ones that recognize when intervention becomes vanity, when effort becomes waste, when restraint becomes wisdom. In this sense, Venus is not a failure of imagination. It is a test of maturity. Do we continue to believe that every problem can be engineered away? Or do we accept that some problems are warnings, not challenges? Venus also strips away the fantasy that Earth is expendable. For decades, the idea of space colonization has been framed as insurance. If Earth fails, we leave. Venus exposes the flaw in that logic. Nearby planets are not substitutes. They are harsher, more fragile, more unforgiving. Earth is not our first home, it is our only proven one. This does not mean humanity should stop exploring. Quite the opposite. Venus makes exploration more meaningful by clarifying its purpose. Exploration is not about escape. It is about understanding limits before we cross them. It is about learning what kinds of worlds can host life and what kinds cannot. It is about humility. Venus stands as the clearest example we have that the universe is not hostile, but it is indifferent. It does not reward intelligence with safety. It does not guarantee second chances. It allows life where conditions aligned and removes it where they do not. That indifference is not cruel. It is consistent. And consistency is what makes Venus so valuable, because it shows us that Earth's habitability is not magic. It is the result of balance maintained, not promised. Venus is what happens when balance slips too far and too long. Earth is what happens when it doesn't. That difference is everything. In the end, Venus is not a paradise lost. It is a paradise that never was only imagined, projected, and hoped for. The real tragedy is not that we cannot live there. It is that we once believed we wouldn't need to care if we couldn't. Venus corrects that belief. It tells us that the future of humanity is not written in how many planets we can reach, but in how well we can preserve the one that already works. That true advancement is not measured in expansion alone, but in sustainability, foresight, and restraint. Venus does not invite us to settle it. It invites us to think about thresholds, about irreversibility, about what happens when intelligence arrives too late. And if we truly listen, Venus offers us a final, quiet gift: perspective. A reminder that Earth is not ordinary. That habitability is rare. That survival is fragile. The sister planet did not betray us. It warned us. And whether that warning becomes prophecy or prevention is no longer Venus's choice. It's ours. Venus ultimately dismantles the most comforting story. Humanity tells itself about the future, that survival is a matter of ingenuity alone. That if conditions worsen, intelligence will rise to meet them. That technology arrives just in time. Venus is the nearest example of a world where just in time never command, where once missed, it could never come at all. This is not a failure of intelligence. It is a failure of timing. And timing, Venus reminds us, is not negotiable. For a long time, humanity assumed that the universe was filled with second chances. New continents beyond the horizon. New frontiers beyond the sky. When Earth's limits became visible, space offered psychological relief, a sense that even if we made mistakes, we could move on. Venus collapses that emotional safety net. It shows us that not every door opens outward. Some close permanently. This reframes what it means to be a spacefaring species. Perhaps the mark of advancement is not how aggressively a civilization expands, but how carefully it learns which environments to protect, which to avoid, and which to leave untouched. Venus suggests that wisdom is not measured by how much power we wield, but by how well we recognize when power is the wrong tool. There is a quiet arrogance embedded in many visions of the future. The idea that planets exist as raw material for intelligence, waiting to be improved. Venus refuses that framing. It exists as it is, complete and indifferent, neither asking for intervention nor permitting it. It does not need us. It does not care about our aspirations, and that indifference is clarifying. Venus shows us that the universe is not hostile to life, but it is hostile to entitlement. Life persists only where conditions allow it to persist. No amount of desire can override that. No amount of symbolism can soften it. This truth is uncomfortable because it strips away the fantasy that survival is guaranteed by cleverness alone. Instead, Venus argues that survival is conditional. This has profound implications for how humanity imagines its long-term future. It suggests that spreading across the stars is not inevitable, and that extinction is not always dramatic. Civilizations do not necessarily end in fire or collapse. Some simply cross thresholds quietly and find themselves unable to return. Venus is a fossil of that process. It also changes how we think about courage. There is courage in exploration, yes, but there is also courage in restraint. Courage in choosing not to gamble planetary stability on the assumption that solutions will appear later. Venus reveals that later is sometimes too late. In this sense, Venus becomes a philosophical filter. It forces us to separate ambition from responsibility and hope from denial. It asks whether our confidence in progress is earned or merely inherited from a past where boundaries kept receding. Those boundaries no longer recede automatically. Earth, seen through the lens of Venus, becomes something profoundly different. Not a stepping stone, but a sanctuary. Not a starting point, but an exception. Earth's climate, its oceans, its breathable air, all of it begins to look less like a default setting and more like an improbable alignment that deserves protection rather than replacement. Venus does not diminish the dream of the stars. It matures it. It suggests that the future of humanity may not be written in how many planets we settle, but in how long we can maintain the delicate conditions that make settlement unnecessary. That the most meaningful legacy of a civilization might be longevity rather than expansion. This is a radical shift in perspective. It does not reject exploration, it refines it. Exploration becomes about understanding, mapping limits, learning where life can and cannot exist. It becomes a search for compatibility rather than conquest. Venus stands as the clearest signpost in that search, pointing firmly toward no. And no is valuable information. In many ways, Venus is the first planet to tell humanity that it cannot be everywhere. That the universe contains not just opportunities, but boundaries. That maturity as a species involves learning the difference. Venus is not a challenge to overcome. It is a truth to accept. And acceptance, unlike conquest, does not inflate the ego. It sharpens it. Venus is not humanity's future, but it is inseparable from humanity's fate. It shapes how we understand risk, time, and consequence. It teaches that intelligence must arrive early, act humbly, and respect systems far larger than itself. The sister planet does not burn as a threat. It burns as a reminder that balance is precious, that thresholds are real, that the universe does not reset, and that the most extraordinary achievement humanity may ever accomplish is not surviving on another world, but ensuring that the one world that works never becomes another Venus. That is Venus's final lesson, not one of fear, but of responsibility. What Venus ultimately dismantles is the idea that the universe is waiting for us to arrive, that planets are incomplete until touched by intelligence. That meaning is something humans bring with them, rather than something constrained by context. Venus exists as a direct rebuttal to that belief. It is whole without us, complete without life, stable without intelligence. Its atmosphere, its heat, its pressure, all of it functions perfectly according to the laws that govern it. Venus does not suffer from being uninhabitable. It does not yearn for oceans or forests or cities. It simply is. This forces an uncomfortable reframing. Habitability is not the goal of planets. It is a side effect. Earth's ability to support life is not evidence of cosmic intent. It is evidence of coincidence magnified by time, stabilized by feedback, preserved by restraint. Venus demonstrates how easily that coincidence can be lost and how little the universe intervenes once it is. This is why Venus feels less like a warning siren and more like a quiet verdict. It does not shout. It does not threaten. It merely persists unchanged, reminding us that outcomes do not require drama to be final. Humanity often imagines the future as a branching tree, multiple paths, endless possibilities, second chances waiting beyond every mistake. Venus shows that some branches end abruptly, not because they are chosen recklessly, but because they are followed too long without correction. In that sense, Venus is not a story of failure. It is a story of delay. Delay in correction. Delay in response. Delay in recognizing thresholds. This matters because intelligence, as we understand it, excels at optimization, but struggles with restraint. We are adept at doing more, faster, bigger. Venus teaches that survival may depend less on acceleration and more on braking. This flips the mythology of progress on its head. Instead of asking how far we can go, Venus asks, how far is too far? Instead of celebrating scale, it highlights proportion. Instead of rewarding ambition, it exposes timing. The planet becomes a kind of cosmic checkpoint, proof that expansion without understanding is not advancement. And that power applied without alignment leads not to mastery, but to exhaustion. Venus also reshapes the ethics of exploration. If some worlds are fundamentally incompatible with life, then attempting to force compatibility becomes an act not of curiosity, but of dominance. Venus resists this not by violence, but by inevitability. It does not punish intrusion, it nullifies it. Every failed probe, every crushed lander, every corroded instrument is not a rejection. It is an indifference so total that rejection becomes meaningless. That indifference teaches humility in a way no hostile alien intelligence ever could. Because an enemy can be negotiated with. Physics cannot. Venus also reframes the role of hope. Hope is often treated as a moral good, something that must be preserved at all costs. Venus shows that misplaced hope can be dangerous not because hope itself is flawed, but because it can delay necessary action. Believing that Venus could be fixed postponed the realization that it could not. Believing that Earth will always be fixable risks repeating the same mistake. The lesson is not to abandon hope, but to anchor it in reality rather than reassurance. Venus encourages a harder, more disciplined optimism, one that accepts limits early rather than discovering them late, one that values prevention over redemption, one that understands that intelligence is most powerful when it anticipates rather than reacts. This is where Venus quietly reshapes the definition of civilization. A young civilization expands outward, testing boundaries, assuming reversibility. A mature civilization learns which boundaries matter and which must not be crossed. Venus is the teacher that arrives when a civilization stands. Between those two stages, it does not demand retreat from the stars. It demands clarity. Clarity about which worlds can host life and which cannot. Clarity about the difference between exploration and escape. Clarity about the fact that Earth is not practice. Earth is the exam. Venus also invites a different kind of awe. Not the awe of discovery, but the awe of consequence. The realization that planets remember, that atmospheres keep score, that energy imbalances accumulate silently until balance becomes unreachable. This awe is quieter than wonder, but deeper. It suggests that the future of humanity will not be decided by singular breakthroughs or dramatic moments, but by cumulative choices made long before urgency is felt. Venus is the outcome of such choices. Moral choices, but physical ones. And that distinction matters. The universe does not judge. It records. Venus is the record of a world that crossed its limits and kept going. Earth, for now, has not. That is the space in which humanity exists, not between optimism and despair, but between awareness and action. Venus does not tell us what to do. It tells us what happens when nothing is done soon enough. In that sense, Venus is not humanity's future. It is humanity's responsibility. Not to save it, not to conquer it, but to learn from it while learning still matters. Because the most haunting truth Venus reveals is this: once a planet becomes unmistakably unlivable, the lesson has already arrived too late for that world. Earth is the only place where the lesson can still be applied. And that makes Venus not a paradise lost, not a hell to be feared, but the most honest teacher in the solar system. Silent, unyielding, unforgiving, and indispensable.